All right, ladies and gentlemen of Algebra 2, this is 12.2, talking about permutations and combinations. So kind of the important thing to remember is that in each situation, basically you're counting the number of ways something can happen. It's just a matter, are you looking at an arrangement or are you looking at a grouping? And I'll kind of explain the difference in a minute. But permutations are something of an arrangement, and combinations are a grouping. So that is kind of your big difference. So if when you look at something, you're trying to figure out, is it an arrangement or is it a grouping? So let's look at the problem. When the manager of a softball team fills out the team's lineup card before the game, the order in which he fills the names is important because it determines the order in which the players will bat. Suppose she has 7 possible players in mind for the top 4 spots of the lineup. Using the fundamental counting principle, how many ways can she assign players to the top 4 spots? Well, if I'm looking at the top 4 spots in the batting order, I'm going to think about it like this. I'm going to think about 1, 2, 3, 4. So if she's got 7 possible players in mind, so that means for the first spot, she's got 7 choices. Now, once you take away that choice, then for 2, she's got 6, 5, 4. So the number of possible ways that she can do this is just going to be 7 times 6 times 5 times 4. It's almost a factorial, but it's only like the top half of 7 factorial. So you're just going to take 7 times 6 times 5 times 4. So that's going to give me 840. So that's 840 different possible combinations. So a permutation is when you're looking at an arrangement. All right, order is important, okay? AB is different from BA. So if I'm taking 2 things, that is going to be what it looks like. All right, mathematically, here's what it is. N factorial over n minus r factorial, okay? N is how many objects there are. R is how many you're taking. So n is the number of objects, r is the number of things you're taking. It's going to be n factorial over n minus r factorial. So there are 10 finalists in figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Please note that this is going to be an arrangement. All right, it's got to be first, second, and third. So out of 10 finalists, you're picking 3, so it's going to be a permutation. So that means it's going to be 10 factorial over 10 minus 3 factorial. So that's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 10 minus 3, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. So cancel, 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 cancel. 10 times 9 times 8, that's going to be 720. Oh, if only there was a way for the calculator to do this for us, it would be so much easier. I'm so glad you said that, because now I can show you how to do it on the calculator and make your life significantly easier. So this is my home screen on my TI-84. So here's what I'm going to do. Since I'm going 10, pick 3, I'm going to start off with 10. Then if you find the math button, which is the 3rd button down on the left, and hit it, this screen comes up. Across the top, math, num, CPX, PRB. PRB is what you want. So if you look at PRB, 2, 3, and 4 are going to be very interesting to you because those are going to be the ones you really, really want. So in this case, we want NPR because it's a permutation. So I hit enter, 3. So now it's 10, pick 3. There's my answer. So once again, it's in the math. Go over to PRB, and that's where I'm at. So the newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? So you've got the same kind of situation. It matters who goes to what story. So mathematically, it's going to be 9, choose 9, pick 4. So 9 factorial over 9 minus 4 factorial. All right? So you can multiply that out and cancel out. And you can do it by hand if you want. It's not a bad habit to get into. But I want to do this. So I'm going to go 9 math PRB choose 4. So that's going to be 3,024. So there's 3,024 possible ways for 9 reporters to cover 4 stories. All right, so how many ways can the letters of the word geometry be arranged? So here you have a permutation with a repetition. How do I know it's a repetition? Because there are two E's in geometry. So how does that change? Well, all I do is take the factorial over the top, and then on the bottom, what I do is divide by everything that repeats. Okay, so geometry's got 8 letters, so that's going to be 8 factorial. But one of the letters repeats, E, there's that repeats twice, so there's 2 E's, so that's going to be 2 factorial. So all that means is I'm going to have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, cancel, cancel. And I can do that in the calculator as well. And I just got to use that other function. So I'm going to go 8, math, PRB, number 4. There's 8 factorial. That's what I want. Now I'm going to divide that by 2 factorial, which is a fancy way of saying 2. So 20,160 is going to be my answer. All right, so if I do that, let's try again. How about Mississippi? Mississippi, good old Mississippi, the problem that always messes with everybody. All right, so 4, 8, 9, 10, 11 letters, but a fair amount of them are repeaters. So S, 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 that's 4 S's. So I'm going to take 4 factorial for that. There are 4 I's, so I'm going to take a 4 factorial for that. And there's 2 P's, so I'm going to take a 2 factorial for that. Now in a calculator, I can't put all this into one thing. But I got to be careful because I got to put parentheses around my denominator. All right, so you're telling me when I say that. So you want to take this, move. So you want to take this and go 11 factorial. Like that. And if you divide, if I just put divide by 4 factorial, 4 factorial, 2 factorial, it's going to be not what I want, okay? Because I want all of my denominator to go together. So I want to go 4 factorial. Then I just go 4 factorial, 2 factorial. But I want that all in parentheses because I want it to divide that entire denominator together. So that'll be my answer, 34,650. That'll be my answer. All right, combination is a little bit different. Combination says I don't care about the order, I care about the grouping. Okay, so if I group 3 people, it doesn't matter if you get picked first, third, or second, you're still part of the group. So orders doesn't matter. A, B is the same thing as B, A. It doesn't matter. This is going to be a little bit different. It's going to be n over n minus r factorial times r factorial. N and r still mean the same thing. You have n objects, you have n things, and you're taking r of them. I have no idea where n and r came up with. It's really weird and random. But that's, sometimes in math we do that. So number 4, a group of 7 students who are working on a project needs to choose 2 students to present the group's project. How many ways can they choose the 2 students? So order does not matter. That's why I use combination. So it's going to be 7 choose 2. So mathematically, kind of the mathematical representation will look like this. 7 factorial, so 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Now times 2 times 1. So cancel, 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 cancel. But now I've still got 2 and 1, and I've got 7 and 6, and 6 over 2 can be divided by 3. So that's going to be 21. There are 21 different ways for 2 people to present a project. So 5 cousins at a family reunion decide 3 of them will go pick up pizza. How many ways can they decide who will go get pizza? Well, does order matter? Does it matter if you get picked first or fifth or third to go get pizza? No, it doesn't matter at all. So this is where you use, instead of NPR, instead of NPICR, you go NChooseR. So I still want 5 I want NCR this time. 3, that's going to be 10. So there's 10 different ways you can do it. So 5 cards are chosen from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? Okay, so for those of you guys that don't know, standard deck of cards has got 52 cards. There are 13 cards of each suit. So there's heart, there's diamond, there's spade, and then there's club. So 13, 13, 13, 13. So now, 3 clubs, 2 diamonds. Does it matter what order they come in? No. I could go club, club, diamond, diamond, club. I could go club, diamond, club, diamond, club. Doesn't matter. Here's what I was going to do. So out of clubs, 13 clubs, I want 3 of those. And out of diamonds, I want 2 of those. So that's all it's going to be. It's going to be 2 combinations multiplied together. All right, out of 13 of each of those, that's what you're going to do. So there you go, 13, math, PRB. If you just hit like 3, it automatically comes up. So 13, choose 3. That's going to be that one. So you get 286 ways to get 3 clubs. You want to multiply that times, I like to put in parentheses just to be safe, math, PRB, NCR. Oop, go. Forgot to put 2 in there. 2, like that. So 22,308 different ways to do that. So that's going to be your answer, 22,308. So how many hands consist of 2 hearts and 4 spades when you choose 6? So it's kind of the same situation. So you're going to have 13 choose 2 for the hearts and 13 choose 4 for the spades. All right, so that is what that one's going to look like. So this is where things get a little tricky. All right, now I'm saying they're not a specific suit, they're just 2 different suits. Here is where you got to kind of look and see what you're doing. All right, so it's similar to number 7 in that you're taking 6 cards and you're taking 2 of one and 4 from another, but now I don't care which suit that is. So how does this change? Okay, well, 2 cards from one suit, here's what that looks like. I still take 13, choose 2, because every suit has 13 cards and I'm picking 2 of them. But now to represent the fact that I'm taking it from any suit, there are 4 suits, I'm going to pick one of them. All right, so this is the 2 cards. This is the 1 suit. Now I need 4 cards from a different suit. So I want 13, choose 4. So this is the 4 cards. But now it's got to be a different suit. So all I do is this. I take away the suit I used over here. So there's 3 suits left, and I'm going to choose 1. So I'm going to multiply all that together. And if you're brave, you can throw it all in the calculator and trust that the calculator did it right. I like to take it piece by piece. So all you're going to do is go like this. All right, so you're going to have 13, choose 2, times 4, choose 1, okay, times, then parentheses go 13, choose 4, times, one more time, 3, choose 1. So 669,240 different possible ways. That's how many ways you can do that. All right, I believe that is it. Come talk to me with questions. Take your time, think these problems out. Thank you for playing. We will talk to you soon. Have a lovely day.